Here is an explanation for the answer to final exam question number 81 in Electricity Demystified, 2nd edition. If you have the printed edition, please refer to page 339 for the question, and also page 339 at the bottom for the relevant illustration, figure exam-13. We're talking about a device called a galvanometer, or a compass galvanometer. What that thing is basically is an old hiker's magnetic compass with wires wrapped around it in a coil-like configuration going from the north to the south, right parallel with the north-south axis. You lay that compass down on a horizontal surface so that the arrow, the green arrow or the directional arrow, points right up at the end. And then you apply a voltage to the wire to drive a current through it. That current through the coil will cause this needle to deflect one way or the other, either towards the clockwise, towards the east, or counterclockwise towards the west. If you only apply a little bit of current, the needle will only deflect a little. If you apply more and more current, the needle will deflect more and more, but never will it quite be able to deflect 90 degrees. Even with extremely high currents, the needle will, the farthest that it can ever possibly go is so that it points straight east or straight west. So this question is showing us a graph that's wrong. It's showing us a hypothetical graph of what we would get if we varied the current through a galvanometer and then looked at the extent of the needle deflection. Well, you can find a graph that is correct on page 132 of this book, Electricity Experiments You Can Do at Home, where I actually conducted an experiment with a homemade compass galvanometer, and I got a graph. I don't know how well you can see it, but it looks like this. It starts out increasing rapidly, and then it kind of levels off, representing the fact that at small values of current, small current levels, at zero, no current, no deflection. 0 milliamperes, 0 degrees. And then it goes up something like this. Doesn't take that much current to get a 30-degree deflection, but then as you apply more and more current, the deflection approaches 90 degrees, which would be either straight east or straight west. But it never can surpass 90 degrees, no matter, even if you drove so much current through the coil that you melted the wire. That needle could never go farther than 90 degrees. So that's what the graph should look like. Figure exam-13, as it's shown in the book, goes like that. That's wrong. How should it, in fact, look? Well, the correct answer is D. It should be a curve that increases more and more gradually as you move from left to right. So the answer is D. And once again, I recommend that you obtain my book, Electricity Experiments You Can Do at Home. One of the direct current experiments in this book, figure DC 22-4 on page 132. It's the 22nd experiment in the repertoire of direct current experiments, and I actually made a graph from experiment using this same number of milliamps, that same number of degrees, and that's what I got. So I know it works. The answer again is D.